Welcome to the Tesseract podcast, where we unlock your power to innovate. Our mission is to empower airmen, connect them to resources, and accelerate change across the Air Force logistics enterprise. Specifically, our team works as an innovation accelerator assigned to the Air Staff Logistics Directorate, where we partner with airmen to operationalize the new sustainment strategy. My name is James, and I'm going to be your host today. On the show with me here today is Major Kyle Gouge McAlpin. He's a Academy grad, went to the 21st in Travis flying C-17s, and they taught UPT at Vance with T-6s. And now he's in the 6th Airlift Squadron at McGuire-Dix Lakehurst when he's not at the AI Accelerator, managing a couple projects that we'll get into a little bit later. Major McAlpin, thanks for joining me on the show today.
Yeah, absolutely. Thank you.
Did I leave out any good parts about your background that you'd like to expound upon there?
No, that's all the important stuff. The 21st Airlift Squadron, the 8th Flying Training Squadron, the 6th Airlift Squadron, and the AI Accelerator. Yep. That's it
awesome.
In a nutshell. Yeah.
When you listed out like that, a couple numbers and locations, it doesn't seem as big, but that's kind of a big deal. You know, multiple airframes, and now at an MIT, MIT Cooperative Research Institution. Would you like to introduce what the AI Accelerator is, actually? Because I'm sure a lot of our listeners are not very familiar, and especially not with how it kind of straddles, MIT and the Air Force.
Yeah, absolutely. So AI Accelerator, basically, we are a partnership between MIT's Massachusetts Institute of Technology, the Air Force, and then a federally funded research and development center, which is under MIT, called MIT Lincoln Laboratory. So they're kind of like a national lab. They're not technically a national lab. They're an FFRDC. And so basically the AI Accelerator is a three-way partnership under a cooperative agreement where sort of like what does each of the partners give? So MIT gives access to all of the principal investigators, the really smart professors that are doing all the best artificial intelligence research, or some of the best artificial intelligence research in the world. The Air Force gives access, so that the funding and access to really hard problems, really hard operationally relevant problems that we hope can also scale to problems of interest to general society. So things like AI ethics, we have projects doing that. And then Lincoln Laboratory is a similar to National Lab. They're an FFRDC that specializes in prototyping for the Department of Defense, and specifically a lot of their work is for the Air Force. So that's sort of the three-way partnership and what we all kind of bring to the table.
That's awesome. And could you just give some examples of the type of projects that you guys are currently engaged in, the major research streams?
Yeah, so I mentioned one there. One of our big mandates is to do artificial intelligence or research artificial intelligence in a way that advances our values. So our sort of like constitutional republic, democratic republic values. And so a couple of our projects are specifically focused on ethics of AI, which things we could think about are like responsible, trustworthy, equitable, explainable. All of those things are sort of like principles of AI that make it ethical to use in and around people, as opposed to other uses of AI that are used to sort of like dehumanize people. So used to oppress or track or sort of like victimize people. That's kind of one of our projects, or one of the categories of projects that we have are on ethics. So that's that. The other two projects that I work on are magnetic navigation. So that's sort of like an alternative to GPS, using the Earth's magnetic fields to navigate. And then CogPilot, which is using human physiology to assess cognitive state for use in really cognitively demanding jobs like flying or any of the other jobs in the Air Force. There are a lot of them that are cognitively demanding or really just hard. That's kind of a quick summary, but we have all of our projects actually on our website, which is another cool facet of the AI Accelerator, which is just aia.mit.edu and aiaccelerator.af.mil.
Awesome. Yeah, I would definitely recommend checking that out. It's there's good information on there in a very readable way, which is not always the case in military websites. So kudos to you guys. Yeah, that's how I prepared for my interview there. I was a Phantom Fellow for the listeners out there, so I'm fairly familiar with this. Those two, MagNav and the CogPilot, are both great examples of where kind of machine learning fits into the fight. Those are, sorry, I'm going to use machine learning interchangeably with AI. And I think that we all should do that going forward, but that's a topic for another.
I don't know if you've heard the spiel on AI that we sometimes talk about. We're doing like the intro. I think it just kind of bamboozles everyone, like everyone hears AI and like, oh, fancy. It's like general intelligence, something's going to take over the world. And really it's the word AI. It's just not that, it's like the term artificial intelligence has been around since like the 50s and it's been around like for so long that it means nothing. Yeah.
Conway's exactly. Game of life.
So I was going to say, even the DoD definition of AI is any system that would normally require human intelligence. And so if you think about that, that is very problematic because that's like your microwave, it times for a specific amount of time and cooks your food for a specific amount of time and then automatically stops by itself. Like normally something like that would require human intelligence. So any software pretty much under this definition, any software ever written is AI, right? And so it's just been around so long, the term has kind of lost meaning because it means everything to everybody. And so to be a little bit more specific, we say machine learning to avoid some of those like quibbles about what is and isn't AI. Yeah.
Perfect. So then what is machine learning as, different from AI? It's a subset, but, could you expound on what that means?
Yeah, sure. So machine learning is kind of getting into the same realm where it's been around for a long time now and means a lot of things to a lot of people. We just mean it to be a little more specific, like a piece of software that can dynamically adapt. So in the case of like deep learning, it can use a large data set and learn from the data set by itself without direct human input, if that makes sense. So that's kind of an example. That's not necessarily verbatim what our publications or what any of the definitions say.
Perfect. Yeah. And to add just a little bit, these are algorithms that have been around for a long time, since like the 50s, these big machine learning, what makes these big machine learning models. But a big difference is now that we have access to computation that we didn't have before. So that's why we're seeing it's kind of scaling up, and you hear about on the news like ChatGPT and think that it can do absolutely everything you ever wanted it to do. Sometimes that's the case. Sometimes that's not the case. But yeah, definitely worth differentiating machine learning and AI. Awesome.
Yeah, and it's also worth noting there's a lot of techniques here too. Like machine learning is just a class of techniques, and there are probably hundreds or maybe now even thousands of specific techniques under that umbrella. And where a technique falls under that umbrella is definitely up for debate, is debated all the time. So yeah, I try to tell people when they're talking about applying AI to their mission set. What you really need to ask, you really need to probably get an ML engineer in the room, and then second, you really need to, as from the operator point of view, so put my operator and pilot hat on. You really should be thinking about what technique best solves my problem. It doesn't really matter if it's AI or ML. Operators really just need their problem solved in the most effective way.
So I'd like to chase that a little bit. You mentioned that you need to get an ML engineer in the room. There's a lot of techniques. What else makes the cost of implementing ML substantial? Why does it take an organization like MIT to, be a sponsor on these projects to make progress on things like CogPilot or MagNav?
Yeah, that's a great question. It's I think about it a lot as the three ingredients that suggest that we're not in another AI winter. I'm sure if anyone's familiar with that idea, but maybe just
quickly go on that.
Yeah.
What's the AI winter?
It's been around since the 50s, and I think most people say that when it was originally proposed, there was a lot of excitement about what it could do for us, and the excitement sort of reached a peak, and then it didn't quite deliver on the maybe overhype, and then so it entered this winter where people stopped really caring about AI/ML because they thought it was sort of like snake oil, and then a couple of new techniques got discovered, developed, and there was a lot of hype on what AI/ML could do for the world again. And really like the compute, the data, and the algorithms weren't there. And it didn't deliver on the massive amount of hype it got. And it entered another what we call AI winter, which is just sort of lack or waning interest in the idea. And so finally, we've gotten to the point where we have pretty advanced algorithms, all sorts of different algorithms for doing machine learning. We have a really powerful and efficient compute. So powerful and efficient computers, basically. And then we have massive data sets that we can use to train machine learning models. So those are sort of like the three things that have the confluence of those three things has really led to the resurgence again, and hopefully made the last AI winter the actual last AI winter, and mean that we're not an AI. We're not going to lead ourselves to an AI winter now. It's being at the top of this hype cycle, if that makes sense. It's like, why are we not at the top of the hype cycle? That's what I hope is the answer.
Yeah, hopefully we're at the bottom of of the next plateau that we'll get to, and we'll never go below that again.
Exactly.
Okay, so the compute, the techniques, and the data. I think if you had a problem and you thought that ML could plug into it, a pretty cursory understanding of kind of the cloud, you could go on to like AWS and kind of price out what some compute costs. So you might be able to at least have a vague sense of what kind of scale of money that requires. Could you speak to the cost of data? And kind of in a domain non-specific way, but then also give examples of within specific domains. What does it mean to generate data or capture data? What's the issues with data quality, et cetera?
Yeah, I think that's another thing that people tend to get a little starstruck by, is the idea of data, because Google does it in very fancy ways. Some of the more mature machine learning organizations do this in very fancy ways. But all we're really saying is, a CSV file, a recording of something. It's just what happened in the past. Some record of what happened in the past is what data is. Most simply, and the thing that will always work, is just a CSV file. Like every machine learning tool can take as an input a CSV, or basically like an Excel spreadsheet, but just really an Excel spreadsheet recording. That's all data is. Where it gets really fancy and hard is the sort of like quality and quantity of data you have to do machine learning on, and that's where us, as I think in the DoD, we get a little bit confused, because we have a lot of data, but I would say very little of our data is what we call training quality data, TQD, which is like machine learning ready data, because the standard from just having data could be anything. It could be a list of zeros and ones. I don't know how to read that. My computer doesn't know how to read that. I don't know what it represents, right? There's all sorts of questions about what it is and what it means. So that's sort of like the worst case, is you technically have data, but no one knows what it is, what format it's in, what it means, what it was collected on, when it was collected, why it was collected, anything like that, right? So that's the worst case. And the best case is you have data that is very well explained. We have it's very highly curated, which is just a way of saying like someone has put a lot of thought into how to structure it and how to label it, right? If you have an Excel spreadsheet, someone just hands you an Excel spreadsheet, it just has a bunch of unlabeled columns and rows. It's not going to be very useful to anybody. But if someone has put in a lot of thought into how to label the columns so that any layperson can just open this Excel spreadsheet and just intuitively know what it means and what's in it, then that what we would call probably highly curated data. There's a bunch of other issues with doing data at scale too. So having, for example, time alignment is really hard. So if you're trying to do something with time series data, for example, which is just like something that has timestamps in the data. So like the row is just you record a data point every second, for example, that's time series data. It's very important that you can effectively align data sets. So if you have like multiple different spreadsheets, how do you know, like how accurate are the timestamps that are on the data points? Do you just have minutes and seconds, and you might not know what day or year it is? So how do you kind of compare those, really like join those Excel spreadsheets to make them equal to each other if you don't have good time alignment? That's, for example, just like one really practical, difficult issue with big data is time aligning. And then how closely can you time align things? If one thing is collecting a data point once a minute and one is collecting every nanosecond, then those are obviously very different data sets, very different levels of sort of temporal resolution or time alignment. So that could be a challenge too.
Yeah, those are great examples. And that's also, it's very easy to conceptualize when you're talking about that. Like sensor data could be an example of what you're talking about. Like you have different, granularities of time sensitivity. But then when you get into the domains where machine learning is currently being applied in these large models, it's a little bit harder to give examples of how difficult it is to get data when you talk about, say, identifying objects in a road or something like that. Google, like you said, has some clever ways of doing this. Whenever you like load up a web page and it has like the CAPTCHA code, you're helping identify what should be identified by vehicles driving down a road, which is really ingenious. And Google can do that. The Air Force cannot do that with a lot of problems. They don't have access to people across the world doing that. So what are some ways that you guys at the AI Accelerator in any of the projects have come up with ways to get data that you need?
Maybe a non-answer, but the best way we've figured out to do this is just to make our own data, honestly. So there's this idea that one of the maybe common like thoughts in data science is that what we call data wrangling, which is like someone gives you just a spreadsheet. You don't know what's in it. You got to figure it out, right, in order to do some sort of machine learning on it. And that idea of like receiving a spreadsheet and turning it into something that can be input into a machine learning algorithm is called data like wrangling or data curation or something like that, right? Some similar term. And the common saying in data science is that about 80% of your effort goes into just getting the data ready to put into a machine learning algorithm. 80 or 90%, sometimes people say. So that it can take an enormous amount of effort, and it's not always actually possible at all. Just because you have data doesn't mean that it's machine learning ready or can ever be made machine learning ready, right? And so an example I use is we worked with a cutting edge sort of innovation unit, and they worked with a contractor who was actually in the contractor's contract. They had to collect data so that it could be used in the future for machine learning. So I said, hey, we're really excited. We have this data set that we've been collecting. Can you explore it and tell us if there's any interesting insights you can glean from our data set? Can we use this for anything? Is it valuable? And so we got a hold of this thing, and we put several hundred hours of a postdoctoral PhD scientist time analyzing this data set, several hundred hours of supercompute time, which in the grand scheme of things is a lot of money of supercompute time into this thing, and spent a year analyzing this data set and trying to figure out what the things meant. We'd go back and basically what it came down to is the way they had collected it was not machine learning ready. And it was so labor intensive and cost intensive to actually make it machine learning ready that we ended up just throwing it out, collecting our own data set. And so an example of that is we would go back to the user and ask, like, great, like this is a huge data set. This is very interesting. This column is just labeled, XYZ. What does that mean? Like literally XYZ, like what does XYZ mean? They say, we don't really know. Like, okay, well, maybe we can work backwards and try to guess what it means and test a couple hypotheses and try to prove that it means this. But if you have 200 columns and you can't figure out what any of them mean, I mean, that's a lot of effort, right? And then same thing, we'd see like duplicated files. And we'd say, some of these files have the same name, right? Why is that? Are they actually duplicate files or what's going on here? Should we just delete half of the files? They say, we don't really know, And so it just made it extremely challenging and really just way too costly to actually use the data set for anything. And so it made it much cheaper. So like we could put hundreds of hours and a lot of money into curating this data set to make it machine learning ready, or we could put that money into just collecting data better in the future, and we'd get way bigger bang for our buck.
The story that you just gave is such a great example of why it is hard to speak off the cuff as to how machine learning ready some problem set is. And that's exactly, unfortunately, what a lot of people want when they, kind of have these ideas where could machine learning help this problem? Okay, so to transition, we've been talking about how kind of complex machine learning is, and how specific problems need to be. And tell me about Puckboard, and tell me about specifically why Puckboard is different from other scheduling apps that exist.
Sure. Yeah. So Puckboard probably is another one of those things that means a lot of things to a lot of people. The idea has been around for a long time and sort of died and reincarnated a few times. But what we mean by Puckboard is basically a application that can help the scheduler do their job. So help a flying scheduler. So the person managing a flying squadron, they have to schedule all their pilots and aircraft, mostly just their pilots. Honestly, the aircraft scheduling is handled separately, as you know. But yeah, just an app that can help schedule pilots. And this turns out to be a really challenging problem in the flying world, because there's all sorts of rules regarding crew rest, like how long the pilots have to sleep and when they can and can't fly, and their currency. So what types of events they're allowed to fly based on the last time they accomplished them. There's just so many rules that it actually becomes a really challenging problem trying to find what pilots you can put on what aircraft, especially when you're really busy. It gets even harder. So Puckboard is really two things. So the first thing it is a just replacement for the whiteboard that schedulers have always used. So pretty much the gold standard about 5 years ago was the scheduler would just have this massive whiteboard, and you would print out each of the pilots' names on a puck, like a little magnetic puck thing, and you'd put the pilot's name on the puck, and then you'd throw a little magnetic puck on the board in the line, like in the slot for the flight he was going to fly. And you may have a whiteboard that showed you a week or maybe 2 weeks or something like that. And you'd have all your flights you had to fill and all your pilots' little pucks, and you kind of throw your pucks into the slots for flights. And so what we did, that's sort of been the gold standard. A lot of you said it still is the gold standard. It's probably still how pilot training does things. It's very, very
before
complicated.
CSVs. Before CSVs, you had whiteboard and magnets.
Oh, they still do it. They don't use CSV.
Before that, blackboards. Yeah. Oh, okay.
Because the computers don't work often enough that it's not worth their time. It's easier the whiteboard does never not work, unless someone throws your whiteboard away or something, or walks into the squadron and moves all the pucks around, which would be like a high order crime in a flying squadron.
A single point of failure. The whiteboard was thrown away, completely relied on.
Yeah. There's a funny story about, we were talking about Kessel Run earlier, but Kessel Run's a software engineering organization out here with us in Boston. We're unrelated to them, but we work in a lot of the similar problem sets. The way they got their start was the Defense Innovation Board went out to the Air Operations Center in LUD, and at the time, the CEO of Google was on the Defense Innovation Board, and he was walking through the Air Operations Center and talking to people about their problems, and he was talking to the scheduler that scheduled basically the entire air war going on in the Middle East. And he said, "What really keeps you up at night? What scares you? What's the big thing that scares you?" And the scheduler says, that when I'm asleep at home, someone comes in and messes with my board, because the entire air war will stop. Just an indication of how important these puck boards are to the average flying unit. The holy grail. That's
amazing. And talk about the holy grail. Talk about a personality-driven way to conduct an air war is having that one dude being completely relied on, and the knowledge that he has bounced around his head and all those rules and stuff. That's
exactly.
Crazy.
Just one guy's brain. Yeah, exactly. And so basically we were like, well, we can solve this problem. We can just write a piece of software to replace this puck board. We can put it on the cloud so that, theoretically it can never be, someone cannot just wipe it clean. We can just go retrieve it from the cloud if computers go down or something like that. And then we can also add in some automation, a little bit of help, because when you're throwing pucks against the board, you have to just know all the rules in your head and retrieve those at will. And if you're really tired and you haven't slept in 2 days and you're trying to remember this a bunch of complex rules and manage this very complex air war, it's very prone to mistakes, and then any little bit helps make you more efficient. So if you can help me with anything, any little rule, you can make the problem way easier. And so they basically said, well, we can automate a lot of this. I'll just give you a computer program to do it. And that was sort of how Kessel Run got its start. Is software development company came in and built this product. I think they say it was in a few months, and it allowed them to completely cancel this massive software contract that was hundreds of millions of dollars. And just the simple automation they did to assist the scheduler doing its job ended up saving something in the realm of tens of millions of dollars in the first few weeks or year of its existence. So that's kind of the origin story.
Tens of millions of dollars as determined by, say, more effective pilot competencies being maintained, or how is that captured?
Yeah, so in that case, they were matching tankers, so air refueling aircraft to receivers. So that was this guy's jobs. He was basically doing the tanker plan. It's what air refueling tankers are going to be out there, and at the time there were a lot of air refueling aircraft out there, just because the problem was so complex. They would just go fly aircraft in circles and wait for like a customer, like a receiver of gas to become available. And sometimes there just weren't any, but that was the easiest way to schedule and maintain sort of the agility or the adaptability, was just to always have someone flying over, like ready to give gas.
Okay, so small sidebar. In the world of innovation, it's pretty rare that when you say something saves you money, you actually mean it just saves you like dollars out of your pocket. So
yeah, exactly.
That's a pretty good one.
It was fuel savings in that case. Yeah,
awesome. Okay, so that's how Puckboard came into existence. So that, I assume that's the first part. The second part is the machine learning fancy part. Would you like to introduce that?
Sure. Yeah. So that was the origin story for Kessel Run, who does scheduling for the whole kind of ATO or air tasking order process, and works for the air operations centers. So there's another type of scheduling, which is at the flying unit. So sort of the squadron scheduler, he probably manages 60 to 100 pilots maybe, and he has to fit pilots into specific flights. So he's not managing a whole air war. He's just trying to fit pilots into specific aircraft on specific days. And so basically the 15th Wing, which is Hickam Air Force Base's Joint Base Pearl Harbor Hickam, they have an innovation unit out there that says, hey, we can solve this really hard C-17 scheduling problem where we have to fit crews into missions and training flights, or we can help out with it. We can just automate some of this gigantic whiteboard, or at least show it to you on the computer and add some sort of minor scheduler assistance features. And so that's basically what they did was they took this big puckboard and put it on the computer. One of the things that enabled, once you put it on the computer, put the schedule on the computer, is applying machine learning to that, because now the system can just record data. They put a lot of effort into recording the data that was on the computer in the form of this puckboard application. And so what the AI Accelerator does is we're calling puckboard.ai, which is sort of like an AI plug-in into Puckboard. And one of the ways you can think about it, it's a little bit cartoony, but one of the simple ways to think about it is the scheduler has this entire schedule he has to build for 2 weeks. So what he could do is just press the big red, like, build my schedule button, and it just automatically fills in all of his flights with crews. It's a little more complicated than that. There's a lot of like preferences and sort of art and magic that go into it, but that's kind of the idea, is to help out the scheduler by helping auto-populate some parts of the schedule, or maybe all of the schedule eventually. Awesome. And so that's where the AI Accelerator comes in, as we're developing that AI plugin for Puckboard.
Okay. Is that sort of functionality what makes Puckboard different from other scheduling apps? If so, could you speak to that a little bit?
Yeah, it's a great question. So basically, this idea has been around for a long time, and sort of what's happened because we have not really given people access to scheduling tools that can help them effectively do their job, as they find a way to solve themselves. And so in the case of Hickam, Joint Base Pearl Harbor Hickam, they just had their wing innovation cell do it themselves. So they developed this tool that solved their problems. And no one else was really doing it for the C-17, so they did it. And one of the things that they noticed is there were other efforts out there doing scheduling, but there were none that were working on the C-17. And our problems are, especially in the DoD, are sufficiently niche that every problem is almost completely different. Even so, between like Marine fighters and the Air Force C-17s, completely different scheduling problem, completely different rule sets that determine how and who and when you can schedule. Just very, very different problems. And they seem sort of similar from a high level because they're both, flying scheduling. But when you actually dig into the details, the needs of the user are very different, if that makes sense. And that's basically what we see when we often hear, well, I'm aware of this other scheduling thing that does the same thing, So maybe Kessel Run. Someone might say like, well, Kessel Run's also doing that. It's like, yeah, they're not really when you dig in, like superficially, maybe squint and look at it funny and like flying scheduling, they must be the same. But really they're attacking two very different problems, which is to say they're solving two different users' problems. One is an air operations center, which has a very, very completely different problem set from a flying squadron scheduler, if that makes sense.
Yeah, that's a great example. It reminds me of kind of a tenet of software development that is, you want to take the smallest possible function and make it separate from anything else. And that kind of like, in a broader sense, that becomes what is known in app development as like microservices that are separate parts of companies that do these very little specific things. So you're saying in the world of getting tools in operators' hands, that differentiation and the kind of what could be seen to the skeptic as duplicative efforts is actually very important in ensuring that the tools are actually relevant. Is that a good summary of what you just said?
Yeah, I think so. And the principle of modularity, I come from an engineering background and talk a lot about the principle of modularity. I know you talk about it in software engineering too. So yeah, that's exactly right. We have a very interesting organization. I was just actually looking on Wikipedia. The DoD, the U.S. Department of Defense, is apparently the largest employer in the world. And that sort of checks with how much money we get every year and the hundreds of billions of dollars every year that our organization receives. So certainly puts us in the very highest echelons of budget and size. And so we have
the breadth of different things going on. Absolutely.
Yeah, and that's what completely separates us, though. So not only are we big, but we have so many different mission sets that are so completely different. For example, like Delta, they have a very hard scheduling problem, but for the most part, their problems are pretty similar, right? I mean, they have slightly different aircraft and pilots that are qualified on different aircraft, but they don't have very different mission sets, right? At the end of the day, the mission set is to move people where they want to go, right? They don't have, aircraft landing on the ice in Antarctica and fighter jets that are patrolling the Middle East and search and rescue assets and airplanes that do like very, very weird things in very, very weird places, which we do. So we have all these niche missions that are complicated and very different from anything that anyone else does, if that makes sense.
That does make sense. And once again, parallel in the app development world, all these different missions come with a lot of different business rules, and to create platforms that are general enough to accept different business rules is very complicated, and it generally rules out things like general machine learning. Is that fair? Would you agree with that assessment?
Yeah. No, I think that's what we've seen in the C-17 world. Is people say like, well, when is this going to be ready to expand? The puckboard C-17 scheduling app, when is that going to be ready to expand to the F-16? You're like, oh man, there is maybe a little bit of overlap there, but we completely need to rewrite the software for the most part to get that to work, and we'd have to figure out what the F-16 problems were, which means we'd have to bring an F-16 pilot or go into the squadron and spend hours and days and probably months talking to them. And that's
which
big
is
bill
not
and a lot
undoable.
Of people. Right.
Yeah.
Right.
And it's not undoable, but it does require a separate line of effort, because it's a big enough problem that you don't want to rope it into something else. You might see both programs suffer if you're trying to combine them.
Yeah.
Okay.
Yeah, that's exactly right. And the other interesting sort of good unintended consequence of having multiple kind of somewhat similar but probably a little bit different efforts going on is that you get a lot of robustness to failure. So some of these efforts just aren't going to work out, so if there's a couple different puckboard or flight scheduling efforts out there, some of them just aren't going to work for various reasons. Maybe the terms of the contract for the software engineering contractor we have don't work out, or they have a really strong champion, but the champion ends up PCSing or something, like moving or something like that, and the project kind of dies because they can't find another really passionate champion. Some of these projects, probably most of them, are eventually going to die, and that gives you, if you only have one project and it's failing, then you're kind of screwed, right? Single point of failure. So that completely eliminates single point of failure at pretty low dollar values in the grand scheme of things for tactical level problems. So the elimination of single point of failure, to the extent that puckboard can be expanded to other platforms, if the other flight scheduling efforts die, then puckboard can with some effort be expanded into all those mission sets, as opposed to just starting completely from scratch would take probably years and a lot more money.
Sure. You kind of touched on something there that I think is another concept that when we think about where's the best bang for your buck software wise in an organization like the DoD, it's easy to lose track of it. And that's you you gave a sense of time early on the answer. Sorry, I lost your exact words, but it's worth it to remember that even the legacy platforms that we interact with daily, they sunset at some point. They have a period of support, and they have a rough patch in their early part of that contract. They have some golden days where they just become totally accepted, and it's like, that's never going away. But then they go away. And you do need to have kind of multiple concurrent things develop, especially when you start accounting for things like proprietary information that some companies have, or the kind of politics of program offices maybe not getting along all the time. Just exactly. another example of why that's super important. So you sold me as a person, Gouge, but for the skeptics out there, how do we differentiate between the good duplicative efforts and the bad duplicative efforts? There's a term that people like to use. How do we ensure that we're good stewards of taxpayer money? That's a heavy hitting, hitting phrase. But do you have an answer for that?
Yeah, I mean, as military officers, we have to be good stewards of taxpayer money. I think that's 100% correct. I think the way that gets interpreted, though, there's a bunch of different ways to interpret that. And the way that I think about it as an operator is, this is a quote I wrote down from Stanley McChrystal in his book Team of Teams that I love, so I've wrote it down. Try to reference it all the time. Is he says, the world has changed. The pursuit of efficiency, getting the most with the least investment of energy, time, or money, was once a laudable goal, but being effective in today's world is less a question for optimizing for a known and relatively stable set of variables than responsiveness to a constantly shifting environment. Adaptability, not efficiency, must become our central competency. And so that's kind of the way I think about, like, it's not necessarily about efficiency. I mean, it is, but first our system has to be effective and adaptable, right? So if your system is not effective, then it doesn't matter if it's cost effective. Like, if it doesn't work, then it doesn't matter how much you're paying for it. It doesn't, like, saving 10% or 20% doesn't matter if it doesn't work. And so that's the way I think
especially
about it.
in matters of defense. Yeah,
exactly. People's lives are on the line. Yeah, exactly. And so that's the way I think about it is in things that are absolutely mission critical, you actually don't want, and as a pilot, and this makes sense, right? Like, single point of failure is really bad when lives are on the line. Single point of failure to me is unacceptable. We typically, now, the sort of standard engineering in aircraft is like quadruple redundant on mission critical systems or flight critical systems, safety critical systems. So if you are working on something that is mission critical, then single point of failure is unacceptable. And so perhaps for things that are just kind of like minor optimizations to the organization, then you can have, one effort. For things that are mission critical and cannot fail, I think it's unacceptable to have single point of failure, just one effort attempting to modernize or innovate something, if that makes sense. So that's kind of the way, like, the razor I use to think about it is, if it's really mission critical, then we should have multiple efforts with different people, different sources of funding, different leadership, different champions, different, everything should be different. And that way, if one fails, we still have a backup plan. We still have something that's hopefully innovating or fixing or, attacking our problems.
Winning the fight.
Yeah, exactly.
Winning the fight. Thank you so much for listening to the Tesseract podcast. This show is how I started to learn about enterprise-level strategy and the innovation ecosystem within the Air Force, and I hope we passed along some learning to you with this episode. If you'd like to engage with our team, make sure to follow us on Facebook, Twitter, and Instagram, and connect with us on LinkedIn. Any references to trademarked, copyrighted, or protected products or services such as books, movies, or businesses are used here for the limited purpose of education and professional development of Air Force Airmen. If you have any questions, please contact us at www.tesseract.af.mil.